Hi everyone. In this video, we are going to see how to find the distance between the circumcenter and the orthocenter of a triangle. Let's suppose we have a triangle ABC, and for this triangle, first I am going to draw the orthocenter, and for that, first I am going to drop a perpendicular from A onto the BC side. Let's suppose the perpendicular landed at point D on the BC side. So triangle ABD will be a right triangle, and similarly, triangle ADC will also be a right triangle. Now I am going to drop a perpendicular from vertex B onto the side AC, and let's assume that the perpendicular landed on point E on the side AC. Now the intersection of these two altitudes will be the orthocenter, and the orthocenter is usually denoted by uppercase H. Next, we are going to find out the circumcenter. Now for circumcenter, we have to draw the perpendicular bisectors. First, I am going to draw the perpendicular bisector of the side BC, and then I am going to draw the perpendicular bisector of the side AC, and their point of intersection is called the circumcenter, and it is usually denoted by the uppercase letter O. Next, I am going to join H and O, and that is the distance that we want to calculate in this video. That is the main challenge in this video. So how are we going to calculate the distance HO? Well, for that we have to form a triangle somehow, and then probably we can use some properties of triangle to find out the length HO. So HO should be the side of a triangle. Now what I am going to do, I am going to join OB, OC and OA. Even though I really don't need to join OA, but still I want to do that so that you can see the circumradius. So here I have joined OB and OC. So OB is a circumradius, OC is also a circumradius, and similarly if we join OA, that will be another circumradius. And now if you are thinking how the circumcircle would look like, well, it's going to look something like this, where O is the circumcenter, OA, OB and OC, each of them would be the circumradius, and the circumcircle would kind of look like this. So our main challenge is we have to find out what is the length of HO, the red line there, right? And to find the length of HO, we are going to utilize the triangle HBO. To get into the real proof, let's first clear up our assumptions. We are going to use the same naming conventions. For the original triangle ABC, the angle BAC would be denoted by uppercase A, angle ABC will be denoted by uppercase B, and angle ACB will be denoted by uppercase C. And similarly, the side length AB will be denoted by a lowercase c, side length BC will be denoted by a lowercase a, and side length AC will be denoted by lowercase b. And as you can see from the drawing, OB, OC and OA, they all are of equal length because they are the radius of the circumcircle. So each of them will be equal to the circumradius, which is usually denoted by uppercase R. So that is the circumradius of the original triangle. Next, we are going to use another concept, which is the distance of the orthocenter from the vertex B. In this case, we are going to use HB, that is the distance of the orthocenter from the vertex B, and that will be equal to 2 times R times cosine of B. We have already derived that in a previous video. I have shared the link in the description. Feel free to watch that video. There we have proved that the distance of orthocenter from the vertex is like this. If the vertex is B, then the distance of the orthocenter from vertex would be 2 times R times cosine of that angle, angle B. Now let's look at a few angles here. First, we are going to take a look at the angle ABE. If you think about the little triangle ABE, that is a right triangle, the angle ABE will obviously be 90 degree minus A, because the angle A and angle ABE and angle BEA, their sum is actually 180 degree. So then the sum of the angle A and angle ABE will be equal to 90 degree. So then angle ABE will be 90 degree minus A, and that's exactly what I have noted here. It's pi over 2 minus A. That's the angle ABE. And next, let's look at the angle BOC. Now what is angle BOC? Well, BOC is the angle subtended by the chord BC at the center of this circle, which will be double the angle subtended on the circumference, which is the angle A. So angle BOC will be 2 times A. Whatever is the size of the angle A, angle BOC will be double of that or 2 times of that. That is a property of circle, that a chord subtends double the angle at the center compared to the angle it subtends on the circumference. Now let's think about the two little triangles there, triangle OBF and triangle OCF. If you think about those two triangles, they both are right triangles because OF is a perpendicular bisector on BC. So both of those triangles are right triangles individually, and OF is a common side, and OB is equal to OC, which is equal to the circumradius R. So obviously the two triangles are congruent triangles, and I have noted that over here. And because they are congruent triangles, then obviously angle BOF will be equal to angle COF. Their sum is 2 times A, and each of them are equal, so that means each of them will be equal to A. Now if that is the case, then what will be the value of the angle OBF? Well, angle OBF will be 90 degree minus A, because if you look at the little right triangle OBF, in that right triangle angle BOF is A, and then angle OBF will be equal to 90 degree minus A, because already angle OFB, that is a 90 degree angle, because OF is the perpendicular bisector there. So then obviously angle OBF will be equal to 90 degree minus A. Now that we know the angle ABE and angle OBF, we should be able to find out the angle HBO. So the angle HBO will be B minus these two other angles. So let me make a note here. So here I have noted angle HBO will be equal to angle ABC minus angle ABE minus angle OBF. Now we know that angle ABC is the angle B, uppercase B, so we can write it as B minus angle ABE is actually 90 degree minus A, and angle OBF is also 90 degree minus A, and let's remove the parenthesis, so this will be B minus pi over 2 plus A minus pi over 2 plus A. So that is equal to 2A plus B minus pi, and in place of pi can we write A plus B plus C, because we know from the original triangle the sum of the three interior angles is equal to pi radian. So in place of pi here I am going to write A plus B plus C. So this can be written as 2A plus B minus A plus B plus C, and again if we remove the parenthesis, this will look like 2A plus B minus A minus B minus C, and you can see that the B will cancel this B, and then this A will cancel one of the A's here. So we are going to be left with A minus C. So we have been able to find out the size of the angle HBO. Now that we know the size of the angle HBO, let me make a note there. So this angle is looking like A minus C, and also we know the length of BH, that is 2 times R times cosine of B, and also we know the length OB, which is actually equal to uppercase R, that's the circumradius. So now if you think about this triangle HBO, we know the two side lengths, we know the angle content between those two sides, so we can easily use the cosine law to find out the value of HO. So let's try that. And using the cosine law, can we write it like this, that cosine of angle HBO will be equal to BH squared plus BO squared minus HO squared, all of that over 2 times BH times BO. And from here let's plug in some values. Cosine of angle HBO can be written as cosine of angle A minus C is equal to BH squared. Now what is BH? Well, BH is actually 2 times R times cosine of B, and then BO squared. BO is actually the circumradius, that would be uppercase R, so that would be R squared there, and then minus HO squared. I'm going to keep that as is. That's the value we have to derive eventually, and all of that over 2 times BH is actually 2 times R times cosine of B, so that is 2 times R times cosine of B, and then times we have BO. BO is actually uppercase R. So from here we can say cosine of A minus C can be written as 4 times R squared times cosine squared of B plus R squared minus HO squared over 4 times R squared times cosine of B. Now let's multiply both sides by 4 R squared cosine of B. Then it's going to look like this. On the left hand side we are going to have 4 times R squared times cosine of B times cosine of A minus C, and on the right hand side we are going to get the numerator there, so that would be 4 times R squared times cosine squared of B plus R squared minus HO squared, and from here I am going to bring the HO squared onto the left hand side, and then everything that is on the left hand side I am going to bring that to the right hand side. So then we can write it like this. We can say HO squared is equal to negative HO squared coming to the left hand side will become positive HO squared. So that will be equal to whatever is on the right hand side. I am going to write that first. 4 times r squared times cosine squared of b plus r squared, and then the quantity from the left hand side will come to the right hand side, so that will become negative 4 times r squared times cosine of b times cosine of a minus c. Now if we simplify this, we can write it as r squared and then minus 4 times r squared times cosine of b times cosine of a minus c, and then plus 4 times r squared times cosine squared of b. Now if you look at the second and the third terms here on the right hand side, we have nice common factor there. The factor would be 4 times r squared times cosine of b. So let's take that out as a common factor. So we can write it as r squared minus 4 times r squared times cosine of b. So that is coming out as a common factor, and then within a bracket we can say then we are going to be left with cosine of a minus c from the second term, and then from the third term will become negative because I have taken negative as a common factor out, so it will become negative now, and 4 times r squared times cosine of b has gone out, so we are going to be left with just a cosine of b. And next what we are going to do, we are going to replace b with pi minus a plus c. So this can be written as r squared minus 4 times r squared times cosine of b times, within the bracket we are going to keep cosine of a minus c, and then minus cosine of, in place of b I am going to write pi minus a plus c, because you know that a plus b plus c is equal to pi radian, so b can be expressed as pi minus the sum of the other two angles. And from here then let's keep r squared as is, and then minus 4 times r squared times cosine of b, and then within the bracket we are going to have cosine of a minus c, and then cosine of pi minus any angle is equal to negative cosine of that angle. So here we already have a minus sign and we are going to get another minus sign, so that will become plus cosine of a plus c. The concept that I used here is like this: cosine of pi minus theta is equal to negative cosine of theta. Think about it. That's exactly what I used here. So cosine of pi minus any angle is equal to negative cosine of that angle. Alright, let's simplify a little more. So this can be written as r squared minus 4 times r squared cosine of b times, within the bracket I am going to rearrange a little bit. I am going to write cosine of a plus c and then plus cosine of a minus c. Now we know that cosine of a plus b plus cosine of a minus b is equal to 2 times cosine of a times cosine of b. In this case, if you consider the angles to be a and c, then cosine of a plus c plus cosine of a minus c will be equal to 2 times cosine of a times cosine of c. So let's do that. So r squared minus 4 times r squared times cosine of b times, we are going to get 2 times cosine of a times cosine of c. So now this is looking like r squared. I am going to take r squared as a common factor out now, so that will be 1 minus, here you are going to see 4 times 2, that would be 8. So it would be 8 times r squared has been taken out as a common factor, so we are going to be left with 8 times cosine of a times cosine of b times cosine of c, and that is actually equal to HO squared. So what would be HO then? Well, we can take a square root on both sides. So from here we can say then HO will be equal to square root of this quantity here. So r squared will become r, coming out of the square root it will stay as r, and then within the square root we are going to have this quantity 1 minus 8 times cosine of a times cosine of b times cosine of c, and that's exactly what we needed to calculate. So that is the distance between the orthocenter and the circumcenter. It is r times square root of 1 minus 8 times cosine of a times cosine of b times cosine of c, where r is the circumradius of the original triangle and a, b and c are the interior angles of the original triangle. Next we are going to take an example. Let's suppose we have an example like this. For a triangle, we have been provided with two interior angles. Angle A is equal to 60 degree, angle B is equal to 45 degree, and the side length A has been provided as 6 cm. And we have to find the distance between its circumcenter and orthocenter. So how are we going to solve this problem? Well, we know that the distance between circumcenter and orthocenter is denoted like this: r times square root of 1 minus 8 times cosine of a times cosine of b times cosine of c. Now here we have been provided with the angles a and b, we can easily find the angle c, and also because we have been provided with the side length a, we should be able to easily calculate r. So let's do that. First let's find out what is c. Well, angle c will be equal to 180 degree minus a minus b, and that will be equal to 180 degree minus 60 degree minus 45 degree. and that will be equal to 75 degree. So we have been able to find the value of the angle C. Next, let's calculate the value of R, which is the circumradius. Well, from the sine law, we know that A over sine A is equal to B over sine B is equal to C over sine C is equal to 2 times R. And now I'm going to take these two portions. So from here we can say then A over sine A is equal to 2 times R, and from here R will be equal to A over 2 times sine of A. Now let's plug in the values. A is given as 6 centimeter over 2 times sine of 60 degree because the angle A has been provided as 60 degree, and let's simplify this. So that would be 6 over 2 times sine 60 degree is actually square root of 3 over 2. So this 2 and this 2, they are going to cancel out each other, and we are going to be left with 6 over square root of 3, and that will be equal to 2 times square root of 3. So we have been able to find the value of R as well, and here the unit of course is going to be centimeter because the length of the side A is 6 centimeter. So here all the lengths will be denoted in the unit of centimeter. So let me make a note of that. So R is equal to 2 times square root of 3 centimeter. Now let's plug in the values in the main formula there. So we can say then HO will be equal to R times. So what is R? R is actually 2 times square root of 3 times we have square root of 1 minus 8 times cosine of A, that is cosine of 60 degree, times cosine of B, that will be cosine of 45 degree, and then cosine of C, that will be cosine of 75 degree, and that will be equal to 2 times square root of 3 times square root of 1 minus 8 times cosine of 60 degree is actually 1/2 times cosine of 45 degree is actually 1 over square root of 2 times cosine of 75 degree is actually square root of 3 minus 1 over 2 times square root of 2. Now how did I find that value? Well, you can easily find the value of cosine of 75 degree like this. Cosine of 75 degree can be written as cosine of 45 degree plus 30 degree. So that can be written as cosine of 45 degree times cosine of 30 degree minus sine of 45 degree times sine of 30 degree. I am just using the formula of cosine of A plus B, which is equal to cosine of A times cosine of B minus sine of A times sine of B. And now if you plug in the values here, then cosine of 75 degree is going to look like cosine of 45 degree is actually 1 over square root of 2 times cosine of 30 degree is actually square root of 3 over 2 minus sine of 45 degree, that is 1 over square root of 2 times sine of 30 degree is actually 1/2. So this is essentially square root of 3 over 2 times square root of 2 minus 1 over 2 times square root of 2, and if you combine them, this will be 2 times square root of 2 in the denominator, that will be the LCM there, and then in the numerator we will have square root of 3 minus 1, and that's exactly what I have written there, that cosine of 75 degree is nothing but square root of 3 minus 1 over 2 times square root of 2. So I'm going to erase this now, and now let's simplify this main expression here. So that will be equal to 2 times square root of 3, and then within the big square root we are going to have 1 minus, if you look at there, 8, and then we have 1/2 times 1 over square root of 2, and then square root of 3 minus 1 over 2 times square root of 2. So if you look at all those denominators there, we have 2, then a square root of 2, then a 2 and square root of 2. Their product is actually equal to 8. So that means they will cancel the 8. So 2 and the square root of 2 and the 2 times square root of 2, their product is actually equal to 8. And they are going to cancel this 8. So we are going to be left with 1 minus square root of 3 minus 1. So we have to write it like this, 1 minus square root of 3 minus 1. And this is equal to 2 times square root of 3. And then within the other root, we have 1 minus square root of 3 plus 1, and this is essentially 2 times square root of 3 times square root of 2 minus square root of 3, and that will be equal to, if you punch in these numbers in a calculator, this will be actually equal to 1.79 centimeter approximately. Therefore, the distance between the orthocenter and the circumcenter is actually equal to 1.79 centimeter, and that is our answer. I hope everything made sense. Thank you for watching. See you in the next video.